This is an MRI viewer. This has a volumetric data set, so you can not only have two spherical angles here, but you also have another set of spherical angles for the cutting plane itself. Hi, my name is Jeff Hahn. I'm the founder and chief scientist of a company called Perceptive. We've been around for about 5.5 years. You know, we're most well known for this kind of work. It's actually a small part of our business, broadcast, but obviously it gets disproportionate media coverage. So a lot of people think that's what we do. And what we're showing here in the Corning booth is the world's largest projected capacitive display, 82 inches diagonal. We've been working on this really hard, and we just launched this a few months ago. And here at the show, we're announcing that we're completely switched to Gorilla Glass for all of our products. So 82 inches is now, we're not just showing the world's largest multi-touch display, but also the world's largest piece of Gorilla Glass optically bonded to the surface of this display. Now, the reason why glass is important is because LCDs actually cannot accommodate force normal to the screen. They're not designed for that. So if you're making an interactive screen that's touch sensing, you really have to protect it with a cover glass. And so you see a lot of displays that actually put a cover glass in front. We really need the cover glass here to be strong and also thin to be right on the image plane itself. Otherwise, you have a large parallax issue. It leads to a lot of UI errors. Gorilla Glass is just the best stuff. It's super strong. It allows me to be this ruggedized, which you don't want to think about doing on an 82-inch TV. And as we look toward advanced technologies like our stylus, it allows us, we actually push a lot of force on the thing. Again, this glass is critical to protect it.
So show me something you might do with the stylus.
We've seen styluses before, and we've seen multi-touch before, but when you combine them together, it really becomes something different. Touch is a very modal technology, user interface. It's actually really great to move photos around, but once you actually want to do something more complicated, it actually becomes a bit of a hindrance. And the reason for that is that you don't know which touch is what. And what the stylus does is allows you to have the precision and the identity that an operation is really what I want to do with my right hand, and I can reserve touch for manipulation. So from a UI point of view, the human body works really well with this division of labor where your dominant hand, usually my right hand, operates a tool or an implement, and my left hand actually acts as a manipulator. And if you can imagine a sculptor holding something, they hold something like this and you operate very much like that. That kind of modality, asymmetrical by the way, is really, really powerful, and the next wave of UI is going to take advantage of that, and that's really what's exciting about Pen and Touch.
You and others have been working on all sorts of different multi-touch displays for a while now, and it seems like they've all just kind of burst at this CES. Was there a technology evolution that made this kind of flowering possible, or something? Why are we seeing something now?
5.5 years ago, I had to explain to everybody what multi-touch was and meant, and then we've seen frankly, some great products from folks like Apple, and really have really executed so brilliantly that everyone really sees what a good implementation can be and have come to expect it. I also think, though, that the explosion of new UI is less about just multi-touch, but an awareness that people finally have it. You don't have to use just a keyboard and mouse. You can demand something else besides that. People are now willing to say, oh, this is something I can try. Touch is something that I can treat as my primary interface. And then as we look to stylus and touch, to gestural interfaces, some people are thinking about brain computing interfaces. I'm a little dubious about that one, but I think that's the high order bit. We have displays in much more interesting places like this. We have mobile devices, we have slates. So as the display industry has pushed, amazingly, pixels to whole different types of form factors, it has also allowed people, it also has carried along with it alternative UI to access those things, those pixels. Because you can't have a keyboard and mouse on a display like this, just like it's inappropriate to have a wall-size display and have an array of keyboard and mice here. You have to start having UIs and input modalities that are more appropriate to the display kind of display architecture.
So what application have you seen that you're most excited about? I mean, obviously there's many applications, but what area of application is your target?
I think our company's focus and my personal research focus is on how to harness these technologies for the knowledge worker, to actually get real work done. Sure, we all know how great casual touch can be for games and for other things like that, but it's a very hard problem to actually say this is important enough this actually can improve productivity sufficiently enough that allows people to want to pay for it, pay a premium over other things. So to me, the biggest challenge is actually, the most exciting areas are things like data exploration, collaboration, when you're actually thinking about how do we actually visualize and then work on data sets in a more, frankly, native way. So this is an MRI viewer. This has a volumetric data set. So you can not only have two spherical angles here, but you also have another set of spherical angles for the cutting plane itself, which I can manipulate, and then the depth along that cutting plane. And then you have actually the viewport within it if I wanted to zoom in there. So there's about 7 or 9 different degrees of freedom that you can manipulate here. And our job is to try to figure out what is the best practice, what are the best modalities for manipulating this type of data set. It's medical here, but what's neat about solving that problem is that once you solve what's the best way to work with volumetric data, you're solving it for a lot of other verticals also, not just for medical. For instance, a lot of work you do in energy exploration also revolves around volumetric data sets. So solve this once here, it's quite applicable to a lot of other domains and that's the way we think of things. We look at things in a data type point of view.
Awesome. And you said this is going to be about 100,000.
It is. We've been shipping this for a while. It's 100K. We're just announcing the fact that it's Gorilla Glass now, which is awesome. Yeah, we're admittedly in the kind of higher end markets, but trust me, this is we like to start at the top and work our way downward. It's a lot easier to to make things more efficient once you actually have the performance there. Then cost optimization is a lot easier than trying to have something that doesn't work so well and trying to get it to work better. Another application that's kind of interesting.
Okay, and so they would be the